Good morning, it's Corbett Lunsford with Green Dream Group in Chicago. I'd like to demonstrate on behalf of Building Performance Workshop while we are on the way to one of our jobs, because there's really not enough time to talk about this stuff, is there? How to do ASHRAE 62.2 ventilation calculation. We've come up with a pretty streamlined calculation thanks to John Bergman here, who actually went to calculus class when he was in engineering school. So we have a way to do it that's pretty simple to understand. It's in 3 easy bite-sized pieces, and then we've got one giant calculation that you can do if you want to just do the whole thing at once. It is possible to do that. So we're going to go ahead and get on the computer right now and show you what's going on with this, and hopefully this makes sense. Okay, ASHRAE 62.2, 2013. It's difficult, not the worst thing that ever happened to you, so I will definitely help you work through this bite by bite. So here we go. The calculation is, to begin, 7.5 CFM for each person in the house. And the way that you figure that is the number of bedrooms plus 1, because there's a couple in one of the bedrooms, is what ASHRAE assumes. So it's not the actual number of people, it's bedrooms plus 1. Plus 3 CFM per 100 square feet of conditioned floor area, CFA. That's the all the stuff that's inside the envelope. Garage obviously does not count into that. So you take these two numbers and you add them together, and then you subtract the actual air leakage that'll come from natural infiltration and exfiltration. You test that with the blower door. So here's how it works. We do the blower door test to figure that out. Then we take the number that we get out of that blower door test and we height correct it, and then we weather correct that. So it's one test, and then we add on to it, and then we add on to that. 3-step process, very simple. I'm going to walk you through this here. So you need, first of all, the blower door, obviously. Second of all, you need an infiltration calculation software like the new DM32 gauge from Retrotech or TechTite software from Minneapolis Blower Door. And then you also need a scientific calculator. This is something that you might not have in your kit. When I turn my smartphone sideways, it becomes a scientific calculator. You should definitely have one of these because you're going to need it for this calc. So first thing you do, set your blower door up, test. You don't test like you always test, not just depressurization or pressurization. What the ASHRAE 62.2 standard says is you need to do both pressurization and depressurization and average them. So you add them together and then you divide by 2. That'll give you an average of the 2. What you need out of this is the ELA, the effective leakage area. And by the way, in my book, Home Performance Diagnostics, what I say is you take the CFM that you get on the blower door and you multiply that by 0.055, but that will give you in square inches. What they want is in square feet. So you divide that number then by 144. Second thing that you do then, you've got that ELA, okay? Now we're going to height correct it. Now, if you're BPI certified and you know the height corrected N factor, that is exactly what we're going to do with this number. So we're going to take this ELA and we're going to add the normalized leakage to it, which is for how tall the building is. Obviously, a building that's super tall is going to have much more stack effect, and so it'll have greater pressures and greater infiltration exfiltration. So what we're going to do is take 1,000 times that ELA in square feet that we just found, divided by the conditioned floor area, again, that was from the first bit, times this orange bit right here. That's the height of the building, divided by the reference height to the power of 0.4. That sounds like fun, right? So what we're going to do is the height is the greatest distance from the ground to the top of the home's envelope, and that is the top of the pressure boundary, not the top of the roof. So it's generally going to be the ceiling of the top floor, and that is divided by a reference height of 8.2 feet. So what ASHRAE is saying is that every story should be about 8.2 feet. So that's what you're doing, is just finding out how many stories this place is. If it's 30 feet high, you divide that by 8.2 and you get this certain number of stories. Even if it is only 2 stories with 14-foot ceilings, they will kind of subtract that out so that you get to normal stories. Now, what you're going to need for this power to the power of 0.4 is this caret symbol, which is right here in the middle of the screen, or the y to the x symbol. Both of those will do the job for you. It depends on what kind of brand of scientific calculator you're using, but that is what you're going to use to get to this 0.4 at the end of the calculation there, okay? So then the next step after we have that normalized leakage for the height correction is we're going to weather correct it for weather and shielding. This is also called the effective annual infiltration rate. So you take your normalized leakage, multiply it by the CFA, the conditioned floor area, and then you multiply that by the weather and shielding factor, which is in orange there. Then you divide that whole thing by 7.3, which is a just static number. It never changes. It's got a bunch of stuff in that number. You don't even want to know what's in there. And the weather and shielding factor comes from the ASHRAE standard. So you need to get a hold of that 62.2 to find the table. It looks like this. It's just a chart full of numbers. It's organized by state, and you find out where you are, and then you basically just plug in the number that they give you. So the ventilation required then is the 7.5 CFM per person plus the 3 CFM per 100 square feet minus what we just got. Now here is one equation that has all of this stuff built into it. This is not in the standard. This is my way of trying to make this easy on you. So you take 1,000 times the ELA times the height divided by 8.2 to the power of 0.4 times the weather and shielding factor, divide that whole thing by 7.3, and bam, you get the number. So here's what we're going to do. Just do an example. We got a 2,500 square foot house in Chicago with 4 bedrooms. It's 22 feet from the grade to the highest point in the pressure boundary. And the blower door test was 1489 for pressurization and 1332 for depressurization. So the first thing that we need to do is do our real quick number calculation. 7.5 CFM times 5 people. 5 people because it's 4 bedrooms plus 1. That is 37.5 CFM. Then we add 3 CFM per 100 square foot for 2,500 square feet of my home. And there are 25 hundreds in 2,500. So I take 25 times 3 and I get 75. Now I'm going to add those two together and I'm going to subtract my air infiltration credit. So I take my big massive equation that I showed you just a second ago that's got it all boiled in there. 1,000 times the ELA. And remember, this is in square feet, not square inches, times the height of my building, which is 22, times the weather and shielding factor. And I run that calculation right there using my caret for that to the power of 0.4. And I get this at the end. I get 112 CFM for my addition portion. Then I subtract the air infiltration credit of 61.36 CFM, and I get 51.14, which really is 52 CFM that I would need to install because I can't find a fan that's going to be 51.14. So I would install 52 CFM at least in that house to ventilate it mechanically 24 hours a day. Now, if you're using the old ASHRAE 62.2 2010, which I don't mean to get too technical on you, obviously we're already there, this number would actually be around 60 or 62. So it's not a huge stretch. It's not a much different number. It's just that they're trying to protect themselves from having people build homes that are really tight without expecting to. So I hope that this has made sense. I'm Corbett Lunsford. This has been Building Performance Workshop. Tune in next time.